So hello everyone, this is the most expected archive series and this is one more question from the then IITJEE and it is from Newton's laws of motion again. Let's see this problem. The system is shown in the figure and it is in equilibrium. The spring and the string are massless, fine, so ideal case is taken. Now the string is cut, the acceleration of mass 2m and m just after the string is cut will be. So just after the string is cut, okay, what happens before that? We'll take this as one system, so internal tension for 2m it will be downwards and for this m it will be upwards, isn't that? So because the tension always is opposite to the masses, fine, tension always has this pull force, not the push force, fine. So can we consider like these two masses to be one system, and if these two masses is one system, so we can say this tension becomes the internal force, isn't that? So can we just neglect it and write for 3m mass it was 3 mg downwards and it was F equals kx upwards, so kx is 3 mg, fine, just before this was cut. And after the string is cut, for the m mass we can write, okay, string is cut now, so there is no tension, so the only force that is acting on m is what? Mg. Can we say mg is force net is mass times acceleration, so the acceleration is g basically. So we got two options. For the m mass it is g downwards and it is g downwards, fine, so one of these two options, fine. Let's study what is happening with this 2m mass. Just after the string is cut, this spring does not retain its initial form abruptly, isn't that? So it still remains in that x elongation. So can we write it is still kx upwards? Okay, just after the string is cut, it is still kx upwards. But what is the gravity downwards? 2 mg now, and the string force, basically tension, is not there because the string is already cut. So can we say F net is mass times acceleration? F net is how much? For example, upwards it is kx was 3 mg, na? So can we say it is 3 mg minus 2 mg equivalent to mass times acceleration? So can we write 2 mg is mass times acceleration? But what is the mass of this 2m, isn't that? The mass for this block is 2m, so don't forget to write 2m there. So 3 mg minus 2 mg is mg divided by 2ma, so mg basically by 2m is acceleration. So can we say the acceleration is g by 2 but upwards, because 3 mg was more than 2 mg. So this is your correct option. And this approach of writing force net equivalent to mass into acceleration, this is the concept that you have to practice a lot in different problems, and I'm sure this type of problem won't be repeated in IITJEE, but you can expect such problems in mains anytime.